Now we have the C4 spreading theory. The C4 spreading theory is acting as a connecting link. This is a connecting link between the continental drift theory of 1912. So the C4 spreading theory is acting as a link between the continental drift theory of 1912 and plate tectonics, right? We have continental drift theory of the 1912, then we have C4 spreading theory and plate tectonics. C4 continental drift theory has a drawback. The mechanism is not proved. So the ocean bottom is 5 kilometers. It is having no sunlight and very cold temperature. Right now, huge pressure at the ocean bottom. The ocean floor may be having that it is having a ridge. Right, a ridge is nothing but a fault. It is having a ridge. At the center of the ridges, there is continuous magma eruption. So the rocks from the center are at an equidistance on both the sides, are of similar age. Now A and B is of similar age and C and D are of similar age. Right. The ocean bottom, this is like 5 kilometers. At the center of the ridge is there, and at the center of the ridge there is continuous magma eruption at the center of the ridge. So at the center of the ridge there is continuous. So at the center of the ridge there is continuous magma eruption. So the ridge is experiencing a continuous magma eruption at the center of the ridge. Now we'll be having that it is called as a center of the ridge and it is having a continuous magma eruption. Continuous magma from the center of the ridge, right? The rocks from the equal distance from the center, equal distance on both the sides, are having similar age. For example, A and B are of same distance and they are of same age. C and D is of same distance and they are of same age. The magnetic properties are also same. Further, the rock analysis C and D are same. If A and D are 10 million years, C and D would be like 20 million years, right? Towards the center, the rocks are very young and towards the distance, they are getting older. Now we say that when the rocks are at the center, they are younger, and when there is a distance, they become older. The oldest oceanic rock ever is just 150 million years ago. But at the continent, we have rocks over 4,000 million years ago. And at the ocean, even the oldest rock is having 150 million years, and they are not older than 150 million years. Therefore, Harry Hess in 1969. So we have the continental drift theory in 1912, whereas the sea floor spreading theory, which is acting as a connecting link between the continental drift theory of 1912, it is in 1961, right? It is by Harry Hess. Whereas the continental drift theory is by Alfred Wegener. The C4 spreading theory is by the Harry Hess. So we'll be having the C4 spreading theory. The C4 spreading theory is by Harry Hess. In 1961, we'll be having the C4 spreading theory is by Harry Hess, 1961, C4 spreading theory, right? We'll be having the asthenosphere is the source of magma, and then through the ridge of the lithosphere, we have the eruption of the magma. Here there is a trench where the plate is going to subsidizes at the trench. Subsidizes at the trench. The plate is going to subsidizes at the trench, and this is called as a mid-oceanic ridge. Harry Hess. So who has proposed the C4 spreading theory? The Harry Hess in 1961 has proposed the sea floor. Harry Hess in 1961 has proposed the C4 spreading theory. So Harry Hess in 1961 has proposed the sea floor spreading theory. The magma from the center adds the oceanic crust on both the sides and pushes the oceanic crust on both the sides. As the magma keeps on adding, it pushes the oceanic crust on both the sides, and if the oceanic crust is increases, the earth becomes bigger, right? Therefore, at the other end, we'll be having other end of the ridge, there are two crusts which are subsiding at a trench. when the magma is created, the same rate we be having the trench, right? Now, as the floor is spreading, continents are moving. Because the sea floor is spreading, we say that the continents are moving. Sea floor spreading theory, the mapping of the oceanic floor, revealed the following important characteristics of the oceanic floor, right? The presence of a mid-oceanic ridges. At the Atlantic ridge, the first thing is going to be like the presence of the mid-oceanic ridges. These ridges are active and there is continuous volcanic eruptions happening. So we say that there is a presence of, what is presence? There is a presence of mid-oceanic ridges, right? So presence of the mid-oceanic ridges. We be saying that there is a presence of the mid-oceanic ridges and the ridges are active over here. So we can say that the ridges are active. Therefore, we have continuous volcanic eruptions happening. Therefore, we say that there is continuous volcanic eruptions over the ridges. So the continuous volcanic eruptions are happening over the ridges. The rocks of the ocean floor are of same age, same composition, and similar magnetic properties on both sides of the ridges. The rocks, we be having the rocks, right? The rocks are having same age on both the sides of the ridges, similar magnetic properties, composition, right? The age of the rock along the oceanic floors is increases. For example, this is 10 million years ago, this will be like 12 million years ago. This is the mid-oceanic ridges, right? This is 13 million years ago. The age increases along the oceanic floor. The age of the oceanic basin is lesser than that of 150 million years ago. It is lesser than that of the continents. The oceanic crust is thinner than the continental crust, based on the evidences Harry Hess in 1961. So the continental drift theory is by Alfred Wegener, whereas we have the oceanic C4 splitting theory is by the Harry Hess. C4 splitting theory is by Harry Hess in 1961 has proposed the theory of the C4 spreading, according to which there is a constant magmatic eruption at the ridges which cause the rupture of the oceanic crust and new lava wedges on the oceanic crust. Hence, we be having new lava which is coming out of the oceanic crust, right? This pushes the oceanic crust on either side of the ridges, and therefore oceanic floor is going to spread. The ocean crust sinks down at the oceanic trench to get consumed, which is subduction. This is what we have the C4 spreading theory. Now, there is another theory called as plate tectonics theory. Now, for the plate tectonics theory, we are considering the entire lithosphere, and then we have the asthenosphere, right? We are considering the lithosphere. Now, what is a lithosphere? Lithosphere is nothing but the crust. So, lithosphere is the crust plus the upper part of upper mantle. So, it is the upper part of upper mantle. This is what lithosphere is. Lithosphere is the crust plus the upper part of the upper mantle is what we have the lithosphere. Right. The crust plus the upper part of the upper mantle is the lithosphere. The plate is a block of the lithosphere. The term plate was coined by J.T. Wilson in 1965 only. Right. The plate is coined by J.T. Wilson in 1965. Plate tectonic theory is proposed in 1967. So we have 1961 is sea floor spreading theory, and in 1912 we'll be having continental drift theory. In 1965 we'll be having the plate tectonic theory, which is proposed by Morgan and separately, and team of Mackenzie and Parker. So the plate tectonic theory, the term plate was coined by J.T. Wilson. So the term plate was coined by J.T. Wilson in 1965. The term plate was coined by Wilson, J.T. Wilson in 1965. In 1967, we have Morgan separately, and then we have Mackenzie and Parker. Mackenzie, and then we have the Parker. So Morgan has separately in 1967 and Mackenzie and Parker, the outer shell lithosphere is broken into multiple parts and it is called as the plate. So what is a plate? The lithosphere which is broken, right? The lithosphere which is divided and it into the multiple parts and it is called as the plates. Everything, the mountain is formed due to the movement of the plates, right? Everything is formed due to the mountain, due to the movement of the plates. Everything, for example, we have mountains, trenches. When the plates are moving, it causes the rising up, and then the trench is also formed over here, where subduction is going to take place at the trenches. And mid-oceanic ridges, where continuous eruption of the lava or the magma and volcanic eruptions is because of the plate's movement. The plate is on the asthenosphere. The single plate may be a continental as well as the oceanic plate. A plate may consist of certain parts which is continental and certain parts which is oceanic as well. So certain parts which is oceanic as well in a plate. A single plate may consist of both the continental as well as the oceanic. Two plates they move away from each other. The lava asthenosphere. Lava from the asthenosphere comes out. When two plates are moving away from each other, lava comes out. Lava, this is the lava from the asthenosphere. When two plates are moving towards each other, one plate has to subduction, right? When two plates are coming next to each other, one has to go down. Is what we have the subduction. The entire part of the lithosphere is moving. How this is different from continental drift theory? In the continental drift theory, Sial is floating on the Sima. Sial is floating on the Sima. This is wrong. Sial plus Sima. We have an entire plate which is going to consist of the continent plus also the ocean, right? In Alfred Wegener has stated that the Sial is in itself floating on the Sima. So Sial is floating on the Sima, whereas this is wrong in the plate tectonic theory. Alfred Wegener says that the smooth movement, but the movement is rigid and resistance between the lithosphere and asthenosphere. The movement is rigid, but we say here the movement is rigid and there is a resistance. We say that we have a resistance between the lithosphere. There is a resistance between the lithosphere and asthenosphere. So there is a resistance between the lithosphere and then we have the asthenosphere. We have resistance between the lithosphere and asthenosphere in terms of plate tectonics. Now, what are the seven major plates? Is American plate, North American plate, South American plate. First, let us complete Americas. North American plate, South American plate, right? Then Eurasia, Europe and Asia plate together is Eurasian plate. So North American plate, South American plate, Eurasian plate. We have the North America, South America, Eurasian plate, African plate, and Pacific plate, Antarctic plate, Indo-Australian plate. Pacific plate is completely oceanic with no continental. Now let us recap it. North American plate, South American plate. Now we be having the North America and then we'll be having the South America, right? After the North American and the South American plate, we'll be having the Eurasian plate. Europe as well as Asia is Eurasian plate. And once the Eurasian plate is over, we'll be having the African plate. Indo-Australian plate. Indo-Australia in Pacific plate is the only plate which is full of oceanic. And after that we have the Antarctic plate. 1, 2, 3, 4, 5, 6, 7. So there are 7 plates. Minor plates like Arabian plate, Caribbean plate, Nazca plate, Scotia plate. Arabia, Caribbean, Arabia, Arabian plate, Caribbean plate, Nazca plate and Scotia plate. So what is plate tectonics theory? Plate tectonic theory, the plates are broad and they are rigid segments of the lithosphere. The plates are nothing but they are the divisions of the lithosphere, segments of lithosphere. So the plates are nothing but the segments of the lithosphere. Lithosphere is going to include the crust plus the upper part of upper mantle. Plate tectonics is the study of deformations within the plates and the interactions of the plates. The plates are getting deformed. So the deformations between the plates and the interactions. Deformations, and then we also have the interactions. So the deformations between the plates, within the plates, and the interactions of the plates around their margin. Plate tectonics was proposed by Morgan, Mackenzie, and Parker separately in 1967. In 1965, the term was coined, right? It was coined by J.T. Wilson in 1965. Now, as per the plate tectonics theory, the lithosphere, which is made up of different plates, it floats on the asthenosphere. The lithosphere is going to floats on the lithosphere is the one which floats on asthenosphere, right? The lithosphere is the one which is going to float on the asthenosphere. The plates are nearly 100 km thickness and have a high rigidity and are able to deform except in response to very strong and prolonged forces. Difference between the with respect to the continental drift theory proposed that the Sial layer is floating over the Sima, whereas the plate tectonics theory proposes that both Sial and Sima are adjacent to each other and they are a part of the lithosphere. The continents float very smoothly over the oceans according to continental drift theory, whereas the plate tectonic theory states that the high resistance is offered by the lithosphere while moving over the asthenosphere. Seven major plates and minor plates. We'll be having Nazca plate, South America plate, right? They are converging, colloid with each other. Diverging is moving away from each other. The divergent is in the mid-Atlantic ridge. Nazca plate and South America plate are converging with respect to each other. The Pacific plate and then we have the North American plate are moving across each other, so they are conservative. Converging, diverging, and conservative. The different plate boundaries are we be having the convergent plate boundaries, divergent plate boundaries, and we also have the conservative plate boundaries. Convergent is they are coming close to each other, right? The Nazca plate and then we have the South American plate. So for the convergent we have two different types of the plates, right? The Nazca plate and then we have the South American plate. For divergent happens across the mid-Atlantic ridge. Conservative plate is the Pacific plate and North American plate are conservative. Divergent plate boundary is a new plate material is built in between. In between, because of the mid-oceanic ridges, there is a new plate material is built in between. We have a new plate material which is built in between. The constructive plate boundary, which is divergent plate boundary is a constructive plate boundary because a new plate is between created in between, right? So divergent is also called as a constructive. Converging is destructive. When two plates are joining together they form trenches, subduction takes place, so there is destruction. Conservative is parallel. Rifting, crack or a fault, division or split, everything is same. Constructive means the plates are moving apart, so new plate is being created. Ocean ocean convergence, continent continent convergence, and then we also have continent ocean convergence, right? Let's see, when an ocean and an ocean is going to, sorry, divergence, these are divergence. Ocean and an ocean is going to diverge. Ocean and ocean are moving separate. In between, we'll be having the rise of the magma. Same situation explained by Harry Hess in 1961. Sea floor spreading theory. The rifting of the oceanic places causes the magma to rise, magma accumulation and upliftment. The breaking of the continental oceanic crust rift creation. Magma rises along the rift and attaches on both the sides. Gradually, the oceanic crust moves. So, the magma is going to rise and it is going to get attached to both the sides of the rift. Right? We have the magma. The magma is going to rise and it is going to attach. The magma rises and the magma attaches on both the sides of the rift. Gradually, the oceanic crust is going to move across. Now we have continent divergent. When the continent and the continent are diverging, the magma is rise. Right, the same magma is having eruption. But here, the plate is going to thin. The edges are thinner because of the melting of the magma. But it is only partial melting, and wide is going to the fault is going to widen formation of the depression. Top view, it looks like a huge gap, right? If the gap is connected with the world ocean, it gets filled with the water, and a small sea is being created over here because continental plate does not melt with the magma as compared to the oceanic plate, which melts very well with the magma. So it leads to the interplate thinning and the creation of the mid-oceanic ridge. Partial melting, widening of the rift, and then we have the shallow plate, shallow sea. So interplate thinning is a continent convergent is the plate is going to thin. Interplate thinning. So the plate is going to reduce its size. It leads to the partial melting and widening of the rift. Widening of the rift. Partially it is going to melt and widening of the rift. Shallow sea. When both the sides of the continental crust are pushed apart, between creation of the oceanic crust cause rising magma in nature. Now continental, in between we be having the oceanic crust is being created. That is what we call it as the creation of mid-oceanic ridge. It still erupts. East Africa is in the first stage. East African Ridge. Example is the East African Ridge. The second stage is the current Red Sea. Africa and Arabia were together once. The third stage is going to be the Atlantic Ocean. South America and Africa were together once. So the East Africa is drifting from Africa is in the stage 1. Stage 1 is explained over here, right? Partial melting and then thinning of the interthinning of the plates. We be having it as the Arabia and Africa. Creation of the mid-oceanic ridge. When the mid-oceanic ridge is being created, it is South America and Africa. Now, the types of the earthquakes experienced are, initially we have shallow earthquake, intermediate earthquake, and then we also have the deep sea earthquake. Oceanic and oceanic divergence, only in the lithosphere 10 kilometer shallow earthquake. The plates are constantly in motion but with different speed in different direction. Therefore, three types of the plate boundaries are created: convergent plate boundaries, divergent plate boundaries, and conservative plate boundaries. Plate boundaries are zone of motion between two plates. Divergence are constructive where the reason is the magma is going to rise. Very rare is ocean continent boundary magma because no ocean continent divergence. Ocean divergence. There are zones of tension where the lithosphere splits or separates and moves apart in opposite directions. Hot magma comes through the cracks, solidifies, and leads to the formation of new crust. Gradually, an elevated ridge is formed along the zone of divergence. This is also zone of shallow earthquake in the ocean convergence. Why not mid-continental ridge? Because magma rising is oceanic in nature, basic magma. Continent is having a divergent. Continent divergence along in a three-state intracontinental rifting. First, the continent is going to rift and the plate is going to thin. So, intracontinental rifting and interplate thinning. It involves fragmentation of the continent by upward movement of the convection currents. So, the plate is being fragmented and the fragmentation is because of the upward movement. This is because of the upward movement. Fragmentation of the plates. We have the fragment. There is a fragmentation of the plates. The plates are being fragmented because of the upward movement. There is a upward movement of the convection currents. The plates are fragmented because of the upward movement of the convectional currents, right? Then in the form of rising plume of molten rock from below. It causes the creation of numerous cracks. So we have numerous cracks and rift valleys. Rising magma starts to come out. Eastern African Ridge is the first. Rift Valley is the first example. Interplate thinning. It involves partial melting of the lithosphere and gradual thinning of the continental plate as being thin. The Rift Valley starts widening and results in the filled oceanic water. Example Red Sea, ocean ridge formation. The continuous spreading of the plates and the creation of new materials along the Rift Valley pushes the continental mass sufficiently apart. At this stage, there will be a new oceanic basin along with the sides of the ridge. Magma coming out less in Al but more in magnesium. It is less in aluminium but it is more in magnesium, therefore leads to oceanic crust formation, and the continental crust never gets created nor destroyed. Now we see a convergent plate boundary. Moving towards each other is what ocean is converging, ocean continent is converging, and continent is converging. When the ocean is converging, one plate is subjected and it is melted easily. Asthenosphere, again it is going to be like volcanic mountains, right? Volcanic mountains over here. So depending upon the plate density, the heavier plate is the one which is going to go for the subduction. So there is a density of the plate density, right? Depending upon this plate's density, heavier plate is going to go down. Ocean part is deepest point is created. Due to ocean convergence, we have the subducted plate will undergo partial melting. The plate which went down is going to undergo a partial melting, right? It starts melting of the plates and accumulate on the other side of the oceanic crust. It is accumulated over here and gradually rise up due to volcanic activity. Magma is coming above the surface. Creation of the ocean volcanic mountain is big. It rises above the water level and appears as an island. So island arc of a single chain, right? Example is that Japan is a subduction of the Pacific plate and the Eurasian plate. Eurasian plate is having some oceanic crust within it. So the subduction of the Pacific plate with the Eurasian plate is the creation of the Japan. Kuril Island and Aleutian Islands are example. In international dateline, Bering Strait. Large group of islands surrounding is what we have called island archipelago. Entire island of the Indonesia is the Indian plate and Pacific plate. So the entire island of Indonesia is the Indian plate with the Pacific plate. Philippines archipelago is Eurasian plate with the Pacific plate is Philippines archipelago. Subduction zone, later magma in all the directions, shifting of the entire islands. All the three types of earthquakes in the convergent, right? Shallow, deep seated and intermediate type of the earthquake. Now ocean convergence is when the same two ocean plates collide with each other. The oceanic plates of higher density descends into the asthenosphere. Right. This process is called subduction, and the region is what we call it as a subduction zone. This leads to the formation of the trenches. So we have the trenches is the deepest region on the surface of the earth. When a Pacific plate collides with the Eurasian plate, we have Japan Trench, Mariana Trench, Kuril Trench, etc. The subducting plate starts melt as it reaches the deeper parts, and some of its molten materials finds its way upwards in the form of the volcanic activity. This molten material piles up continuously on the adjacent oceanic floor, forming the volcanic islands. The continuous volcanic activity gradually increases the size and elevation of the volcanic islands. Experiences a very good amount of compression and maximum stress resistance. The subducting plate experiences a very great resistance and friction, due to which a large number of earthquakes is going to occur. The zone of large number of earthquakes near the subduction zone is known as the Benioff zone. Near the subduction, here it is going great. Subduction there is a zone where high number of earthquakes is going to occur, and this is called as a Benioff zone. Is a zone of high amount of earthquakes along the subducting plate. The volcanic islands are arranged parallel to the trench in the form of an arc and an island arc. Example Japan, Aleutian Island. Archipelago is a group of islands which are scattered in the ocean. They are formed around the ocean convergence plate boundary with intense volcanic activity and shifting tectonic plates. Example is Indonesia and Philippines. Subduction zones are the site of most widespread and intense earthquakes. In the case of the ocean-ocean convergence, all the three types of the earthquakes like shallow, intermediate and deep-seated earthquakes are found. Now continent-continent convergence. The oceanic plate is the denser plate, so it is going to converge, and here the magma is going to, the plate is going to melts in the asthenosphere and comes out in the form of magma and volcanic eruption over here. It results in the formation of the trench, right? Huge compression, subduction zone, trench, continental crust is more rigid, it leads to folding of the continental crust and more violent continental crust, and it is violent and rigid. This melts and starts to rise in the already fold mountains, erupts as a magma. Ocean-ocean convergence is volcanic eruption, volcanic island, fold mountains and volcanic eruption. And in the continent-continent convergence, we do not have magma. Example of ocean is converging is the Andes and Rockies. Peru, Chile, trench in the Andes. Del Salado is located along the border of Chile, Argentina. Is the largest active volcano. Continent-continent collision. Along the world, every plate, continent and oceanic except Pacific plate, is entirely oceanic plate. Before two continental plates collide, between there was a oceanic plate. So continental ocean continental plate and the ocean continental plate collides, and next we'll be having continental plate. Next example is the Indian and Eurasian plate. Continental crust, oceanic crust and the continental crust. This is entirely subducting first, and it results into the fold mountains plus the magma eruptions. Now this continental plate along with this continental plate is going to collide with each other. First it is going to subduct and it forms a sediment, right? Then we will be having the two plates are going to collide with each other. Compression, it results in the formation of fold mountains. Volcanic plateau is because of the volcanic eruption of the oceanic plates. The entire oceanic crust is subducted. Continent is moving converged. It is a partial subduction. It cannot undergo complete subduction because it is lesser in density than the mantle. It cannot subside. It has high resistance. Between 1 and 2, the sediment's entire force of compression leads to the formation of fold mountains. There's no subduction. The mountains are very tall. Example is Himalayas. No volcanic eruption because there is no subduction, no melting, no magma. Ocean continent is having magma, but continent is having no magma. Ocean continent has led to the Tibetan plateau. Continent is Himalayas. No Benioff zones, only along the subduction zone, partial subduction and 70 km, intermediate and shallow zones. And conservative is Pacific and North American plate along the mid-oceanic ridges. They are parallel plate boundaries. Along a mid-oceanic ridge, we have another mid-oceanic ridge. So these two are now being parallel, right? San Andreas Fault is the example. Karakoram range is formed before the Himalayas, right? It is volcanic. So the Karakoram range are formed before the Himalayas. Therefore, it is volcanic because of the ocean-continent conversion of the Indian plate with the Thesis Sea. Then Indian plate and Eurasian plate started converging. Transform plate boundary is also having no volcanic eruption but violent earthquakes at the shallow zones. Right. There is no ocean continent divergence because even when the oceanic plate is diverged, again an oceanic plate is formed over here. When there is a divergence, there is shallow earthquake and no subduction. When there is subduction is going to involve, there is going to be all the three types of earthquakes. Ocean divergence is oceanic sea spreading. Ocean convergence is going to result into island. Continuous force of magma in the ocean divergence. Ocean continent divergence is no force upwards, just melting and forming of the islands. Forceful magma is the reason for the plate separation. Greenland and Iceland are formed due to the ocean divergence. How can ridge attain this much height? The mid-Atlantic ridge along the Atlantic Ocean is very active. Earthquakes, tsunamis, cyclones, volcanic eruptions, and plate tectonics. Plates moving away from each other towards each other. Magma. Convergence is gradual, magma comes out, so no violent activity. Subduction zone is the convergent boundary. Trenches are Pacific Ocean surrounded by the trench subduction except the southern part. Mid-oceanic ridge, right? So in the mid-oceanic ridge, the Atlantic Ocean, Indian and the Eurasian plate, partial subduction, Italy, and then we have the volcanoes, Indian and the Indonesian plate. These are example, and this is the map. Plates are moving away from each other. We have friction. Rising magma pushes only the shallow earthquakes. Subducting, we will be having the convergence, slow volcanic activity, rich volcanism. Subduction is going to build up the pressure and volcanic activity. This is compression between two different plates, no subduction on fold mountains. Ocean, and then we have the continents is when we have the fold mountains plus volcanic eruption happens over here. When an ocean and a continent is going to converge. This type of interaction occurs when a plate is carrying oceanic crust. The oceanic crust is going to collide with the plate carrying the continental crust. The continental crust being more buoyant, that is a lighter. The continental crust is being lighter, forces the denser oceanic crust into the mantle. It goes into the mantle. Example, the Nazca plate and then the South American plate. Subsiding below the South American plate, oceanic continental. During the subduction, the thick sequence of the rocks along the continental margin is compressed. The rocks along the continental margin is the one that undergoes compression and deform to form a chain of fold mountains. Example, Andes and Rockies. As the oceanic plate subducts, it creates the trenches. Earthquakes are generated at Benioff zones. As the oceanic plate plunges deep, it gets melted and starts to rise. This rising magma will be emplaced in the underlying continental crust, which may eventually migrate to the surface, leading to the formation of volcanoes. Subduction of the Nazca plate below the South American plate resulted in the volcanoes of the Ojos del Salado, Cotopaxi, Chimborazo, etc. on the Andes. Ocean continent convergence collision results in all the three types of the earthquakes: the shallow, intermediate, and the deep earthquakes. The Pacific Ocean is surrounded by trenches on all the sides, which are the zones of intense volcanic activities and earthquakes, which are given the name Pacific Ring of Fire. Continent convergence, when two plates carrying continental crust collide, it results in the continent convergent plate boundaries. The collision of the Indian and the Eurasian plates. Prior to the continental collision, the landmass are separated by the oceanic crust, and as these plates converge, the intervening sea encloses and the seafloor subducts beneath one of the plates. The continued convergence results in the complete subduction of the oceanic crust, and the two continental masses get stitched together. Stitching is going to happen as it is called as a suture zone between India and Eurasia, and then we have the ITSZ, Indo-Tibetan Suture Zone. And the continental margins, they continue to collide. The low density of the continental material does not permit its subduction. The oceanic material is completely breaks from the continental block and completely gets assimilated in the mantle. At this point of time, volcanic activity stops. The continued convergence of the continental crust towards each other pushes one of the continental crust partially under the another one, and the sediments are deposited in the basins between the two continental mass, gets folded and creating unusually thick layer of the intense folding. This results in the formation of very high fold mountains. Example in Himalayas. In this type of convergence, we can observe that both shallow and intermediate earthquakes, but not the deeper ones. Conservative or the transform plate boundaries. At a conservative margin, the plates slide past each other without any formation of new crust. This boundary is called as a parallel or the transform plates boundaries. The boundary roughly is move parallel to the direction of the plate. Example, San Andreas Fault of California, where we observe the transformation fault along with the parallel boundary. Transform faults are also found in the oceanic crust where they offset the oceanic ridges throughout their length. Now, landform features. When the ocean and the ocean is going to converge, ocean and the ocean is going to diverge, it is going to cause a mid-oceanic ridges and a transform fault as well. Earthquakes is shallow earthquakes, and volcanism is present. Example, mid-oceanic, mid-Atlantic ridge. And the continent and continent is going to diverge. Here we will be having the presence of a mid-oceanic rift valley. Again, this is called as rift valley. Ridges and then rift, and then a shallow sea is also being created over here. Mid-oceanic ridge is also being created. Earthquakes is also shallow in the divergence. Volcanism is present. Example is the East African Ridge Valley. And the ocean and ocean is going to converge. It results in the formation of subduction zone, trench and subduction zone. Benio of zone is where the intense earthquake is being observed over here, and island arc, archipelago, shallow deep intense earthquake. In all the convergence we'll be having the shallow deep and intense earthquake, whereas conservative we'll be having the shallow earthquake. And magma volcanism is present in the ocean and ocean convergence, ocean continent convergence, but not in the continent continent convergence and conservative plate boundaries. The example for the ocean ocean convergence is the Pacific and the Eurasian plates for leads to Japan. Indonesia is Indian and Pacific plate. Philippines is Pacific and Eurasian plate. Now we have Rockies and Andes are because of the ocean and continent convergence. Continent convergence led to the formation of Himalayas. Conservative plate boundaries led to the formation of San Andreas Fault.